Hello everyone, welcome back to our Algebra 2 class. Today we are going to continue to talk about sequence. In the last lesson, we actually talked about a type of formula. So let's do a quick warm-up to start our lesson today. So as you can see, a sequence is defined like this way, and we need to find the first four terms. So according to what we did last time, we mentioned this one is called general term formula because an is defined by n. So that means we can just, n is index number, meaning n can be a counting number 1, 2, 3, 4, and forever. So let's use this feature to figure out the first four. So first four, and it's going to be 1, 2, 3, 4. So all we need to do, we just replace n as these numbers accordingly. Sorry. So all we need to do, replace n according to this formula, and we just finish the calculation for these four terms. So, and also we mentioned before, this is called general term formula. What does that mean? We can use n, the index number, obviously a counting number, to define any term in a sequence. And this one is very convenient for us to locate any random term in a sequence. We can just easily to do a, for example, if we want to find a27, all we need to do replace n equal to 27 for this sequence. Okay, so today we are going to introduce another formula. So a sequence can be defined in a different way. And before that, let's quickly review some symbols we use in a sequence. As we mentioned before, we use an to represent any nth term, and sometimes we use, fn. It's actually the same thing. And sometimes if we use, for example, an minus 1 or fn minus 1, that indicates a n minus 1th term. Probably it's a little bit weird to hear that, but think about it. If an, for example, n equal to 5, a5 is a 4 fifth terms, right? And n minus 1, meaning it's going to be a4. So you can imagine this is the term before nth. So according to the location, it's going to be a4, then a5. So n minus 1 is a term before nth term, and n plus 1, then it's going to be n plus 1 term. So that's actually, for this case, it's going to be a6. Then you can imagine it's a4, a5, a6. Then a6 is going to be the term after a5. So n plus 1 is a term after an. So sometimes we even use, this n to indicate random position. But if you look at this tree, you will see, oh, this is one in the middle. This is one before an. This is one after an. It's just location, okay? So I want you make sure the order of these terms make it clear in your mind when you see the symbols. So let's see how do we see this one. So this one is called recursive formula. So what does that mean? So recursive formula is defined like this way. So the first time you see this, probably a little bit confused, but let's do a quick analysis to see what do we know about this sequence based on the given information. First of all, when we say f1 of equal to 1, meaning the first term is 1, because f1 is 1, meaning the first term is 1. So the little bit confusing part is coming from the second one. Some students, it's easy to say, oh, do I need to do n is 1, then n plus 1 is 2? My suggestion is try not to just replace n as different values to do this. If you think it's, you're feeling comfortable to do this, do so. But let's figure out what's, relation telling us for this uh, equation for the second one. We know fn plus 1 is a term after fn, next term, right? And fn is the current term. Think about it this way. As we just mentioned, according to the location, fn plus 1 is the term after fn, the current term. So this one telling us, in order to get a next term, we need to plus 4. That's it. Add 4 to get the next term. So that's how we use this one to understand this. So now let's quickly to use this one to do some practice. For example, if I want to find the second term, we know the first one is 1, then the second term, in order to get the next term, I'm going to add 4. So that means I'm going to add 4 from the first term, which is 1 plus 4 is going to be 5. Same thing, if I need to find the third term, then I need to add 4 from the second one. So in order to get a next term, I'm going to add 4 for the next term. So 5 plus 4 is going to be 9. Continue doing that. So the fourth term is going to come in from the third term because the third term plus 4 is equal to next term. So the recursive formula is always telling us the relation between two consecutive terms. That's the most important thing we get from recursive formula. In order to get next term, we always need to find the previous term to get the next term. I'm going to repeat what I said. So in recursive formula, in order to get a new term, the next term, you always need to get from previous term. For example, in order to get f4, you need to know f of 3. In order to get f of 3, you need to know f of 2. In order to get f of 2, you need to know the first term. So that's why the first term is given, because without this information, there will be no way for us to define any sequence in this way. So next we are going to do 2 examples to quickly summarize the lesson today. So the first one, as you can see, the sequence defined this way. We need to know the f of 4. As you can see, the term, even we know fn, but this one is defined by using n, so this is called a general term formula, meaning I use n to define any term. So to find f of 4, all I need to do, replace n as 4, and I'm going to get f of 4, right? So this is a general term formula. We can find any term, in the sequence by replace n as that indicated number. Let's check this one. This one, as we just mentioned, if we see any 2 terms defined like this way, and also we notice the given term is f of, and also we know the first term, this is recursive formula. And we need to understand the 2 things. First term is 1, and then we use this one to tell us the relation between any 2 consecutive terms. So this one is a term before this. So as we can see, in order to get next term, what do we need to do? Come to this one, times 2, then subtract 3, right? So this is the most important thing we need to do. So some students might say, since I need to get f4, let's just replace f of 4 n as 4. But as you can see, if I replace n as 4, according to this definition, I need to get from f of 3. But do we know anything about f of 3? No, we don't. So that's why we are going to start from the first term. First term, f of 1 is already given. Next term, according to this relation telling us to get the next term, we need to multiply 2, then minus 3. So it's going to 2 times the first term, then minus 3. So it's going to be 2 times 1 minus 3. It's going to be negative 1. Again, in order to get the next term, we multiply 2, then minus 3. So it's going to be 2 times negative 1, because this is the second term, minus 3. So it's negative 2 minus 3 is going to be negative 5. Then continue, f of 4. So the f of 4 from, to get f of 4, you need to do this from f of 3, which is multiply 2, then minus 3. So 2 times negative 5 minus 3 is going to be negative 10 minus 3, so negative 13. This is our final answer. So this is, how we use recursive formula to define the sequence. Recursive formula telling us the relation between the two consecutive terms, but general term formula telling us how do we use n, the index number, to indicate any random terms. Okay, I hope this video is helpful for you to understand two types of formulas here. Please rewatch this two example if you need more help. And thank you so much for watching this video to study this topic with me. Take care, everyone.